Hello everyone, my name is Suman Shah and today I am presenting my project on Splunk Multi-Site Multi-Cloud Clustering. Leveraging the strength of AWS and Azure, this project is focused on deploying a robust log management solution that ensure high availability, disaster recovery, scaling, and centralized monitoring of enterprise environment or enterprise log. Let's dive into the high-level details. So, coming to the introduction, Splunk is a powerful platform for analyzing machine generated data, enabling real time monitoring, alerting, and visualization. The goal of this project is to build resilient architecture of deploying Splunk across Azure as a primary site. If you come to my screen, so here we have defined the top part of this architecture is deployed on Azure, and the bottom part we are deployed it on AWS. We come into details in more, and these both sites or both cloud infrastructure are connected to a network peering between Azure and AWS. So in this, Azure we are making as a primary site and AWS as a secondary site. The dual cloud as strategy ensure cross-cloud redundancy and fault tolerance, which are essential for maintaining business continuity in critical scenarios such as natural disaster recovery or system failure or cloud service failure. The core objective of this project include log collection and indexing, efficient integration of data from sources like server, application, network, cloud services like VPC, ELB, CloudTrail, CloudWatch, security guard duty, apart from Azure Defender for Cloud, Azure Defender for Endpoint, Cloud App Security. There are a lot of applications which we integrate. High availability, the data replication across site to avoid downtime, scalable deployment, dynamic scaling to support increase in data volume. If the data volume increase rapidly, we can easily scale up the environment without having any downtime. So for the disaster recovery, we have automatic failover done on this, the bottom part, AWS infrastructure, which is acting as a secondary site as we said in the initial phase. So it has the failover capability from Azure to AWS. And these all are getting centralized monitored within the Splunk itself. So technical architect, if we go very high level, if we go, Azure, as I said, is Azure with the virtual machine hosts the Splunk component like search heads, indexer cluster master. Here we have indexers and heavy forwarders. So a couple of heavy forwarders we have deployed within the infrastructure. And to store these data, we are using Azure Blob to use long data retrieval or data archival. And to support this infrastructure, we are using a couple of other load balancers from Azure services for smooth traffic and smooth traffic operations. At the same time, Azure AWS infrastructure is a mirror of Azure deployment as a disaster recovery plan component like EC2s, which are supported by S3 bucket for replication and failover. So in AWS, S3 buckets are used for cross regional replication of data across multiple regions. So these entire infrastructure are deployed considering security, considering the security in fact. So in this, we have deployed the entire architecture on HTTPS traffic, which is supported by TLS 1.2 to ensure secure communication across the component. Role-based access control is there, automatic failover from Azure to AWS in case of disaster. In case my entire Azure infrastructure goes down, the entire failover go to AWS. Vice versa, if AWS goes down, the entire log onboarding can go and user access can be done through Azure. Will be in active phase. Dynamic scaling support for unpredictable log volume, ensuring the consistent performance. Splunk can be used into multiple use cases and presentation like IT operation. It helps organization to monitor server performance, dedicated system anonymity, track KPIs in real time. Apart from the security monitoring, ensure any threat detection, compliance reporting like GDPR, HIPAA, PCI DSS, NYDFS, any sort of compliance. Disaster recovery, as I said, with AWS as a backup, the system will ensure uninterrupted operation during the site level or cloud service level failure. We saw the same kind of failure in the month of October 2024 on Azure, where the couple of Azure services was down for more than 8 hours, which impacted the business as well. Business scalability, the architecture is ready to scale, future ready for scaling without having any downtime. We can scale up the architecture as much as per our requirement. So apart from that, network bandwidth, ensuring the low latency between the Azure and AWS log sources because of the network pairing, AWS and Azure network pairing. Cluster synchronization is done so that the data can be retrieved from multiple locations for better user experience. Configuration of RBAC control, where the data access will be residing to the specific people, where no data is getting onboarded or data is getting shown to unauthorized person. If I come to the conclusion of this presentation, this project demonstrates a power of multi-cloud architecture, delivering resilient, scalable, and secure log management solution. Splunk multi-site, multi-cloud clustering ensure business continuity under critical failure and provide organization with the tools that need to stay ahead in the data-driven environment or data-driven world. So thank you for your time. I'm looking forward for any questions during our session. But yeah, thanks for my session.